All right, so we're going to be continuing our discussion of radicals, and in 8.1 we really just worked with radicals that had numbers underneath and then products and quotients of those. Today's lesson, the title is a little bit deceiving because we did multiplying and dividing radicals in the last lesson, but the entirety of 8.2 is focused on radicals that have variables in them. So even though we are still multiplying and dividing and using some of the same rules, because they have variables, it looks a lot different. So again, in this section, there are two separate quizzes. So just so you're aware, these first three examples are for quiz 1, and then the second two are for quiz 2. So your choice whether you want to watch the whole video and do both or just pause after example 3 to do the first one. So example 1, we have, you can see here, a product. We're multiplying these radicals. And part A says, what inequality represents all values of x for which the product is defined? So this is just saying, what is x allowed to be? Remember that the rules in general that we're following is that we can't have negative numbers under a radical, and you can't have 0 in a denominator. So anytime we're asking where the product is defined, we're basing it on those rules. So with this product, because I have x plus 2 under the radical, I know that x plus 2 has to be greater than or equal to 0 because I'm not allowed to have a negative. So greater than or equal to 0 means that I don't have a negative underneath the radical. Likewise, that means that x minus 7 has to be greater than or equal to 0 so that I don't have a negative under that radical. If I solve each of these inequalities just by simply subtracting the 2 here, so x greater than or equal to negative 2 here, add 7 here, x greater than or equal to 7. Now, I have two separate reasons, and you can bet that both of these are going to be choices in multiple choice. But if x is greater than or equal to 7, that means it's already greater than or equal to negative 2. So you're looking at the two numbers and you're basically choosing which one's bigger in this case. So I know that x overall has to be greater than or equal to 7 in order for my values to be defined, to not have any of these things that aren't allowed in math. Part B asks what radical is equal to the product above, so actually performing the operation. So that means, just like we did with the numbers, that I'm just going to multiply what's underneath the radicals. So this is the same as this, but most likely they're not going to list an answer choice looking like that because they're probably going to FOIL that out. So x times x is x squared. X times negative 7 is negative 7x. Insides there give me 2x, and then 2 times negative 7 is negative 14. Combine like terms, and I get the square root of x squared minus 5x minus 14 for as simplified as I can get it. All right, in example 2, we are simplifying all of these, and they're telling us that we already know that x is greater than or equal to 0. So we don't have to worry about that restriction here. My suggestion, like I said in the 8.1 video, is to break things down. So here, 12 is 2 times 6. And here I have a 6. Now 6 and 6 can both break down, but because I've already found a pair, I really don't need to, because 2 6s underneath the radical means that 1 6 can come out. So I know I'm going to have a 6 come out. Now the thing that we're adding in this section is I have now an x cubed times an x cubed under the radical. So again, that's a pair, which means that an x cubed gets to come outside as well. Now the only thing that isn't circled, that didn't have a pair, is this 2. So that's what's stuck in the radical. I got a 6 that gets to come out, an x cubed that gets to come out, and then I just have my radical 2 there. Same idea here on B. I can break 30 down into 5 times 6. And the reason I'm doing that is because I can circle a 5 and a 5. 6 breaks down into 2 times 3, but that doesn't give us any additional pairs. So right now we have a 5 that gets to come out. Here, I don't have an x cubed and an x cubed like I did before, but I have an x and an x squared. So remember that what that means is that essentially, if I have x times x squared, I really have x cubed, which is the same as x times x times x. So if I look at it this way, here I do have a pair of x's where I get to bring an x to the outside. So I circled a pair of 5s, I circled a pair of x's, so 5x comes to the outside. Here, the 2 and the 3 don't get to come, so 2 times 3 is 6, and this x doesn't get to come. So I have a 6x underneath the radical this time. So it's okay when you simplify to still end up with a radical or a variable underneath. On C here, we have a product still, but this product has fractions. So keeping in mind that when we multiply fractions, we do top times top and bottom times bottom. So 4 times x cubed is going to give me 4x cubed. And then on the bottom, x cubed times 64 is going to give me 64x cubed. Now, when I have these, in our last video, we went over how you can reduce things that are in front of radicals with other things in front of radicals, things underneath with other things underneath. So I can actually just reduce this fraction first if I want. So 4 and 64 are both divisible by 4. 4 divided by 4 is 1. 64 divided by 4 is 16. I can also reduce my variables here. X cubed divided by x cubed is 1. So those cancel out. So now I'm left with the square root of 1 over the square root of 16, which, remember that here we use the principal roots, so just the positive. 1/4 would actually be my final answer there. Same idea here in D. So if I multiply straight across, I've got 3x cubed in the top and 27x squared in the bottom. And it doesn't matter whether I write it with 1 radical or I write it with 2 like this, we still do the same thing. I'm going to reduce, so these are both divisible by 3. 3 divided by 3 is 1. 27 divided by 3 is 9. Then I've got x cubed and x squared, so in these cases, remember when you have division, you subtract the exponent. So 3 minus 2, I have x to the first left in the top, so just an x. So I have 1x in the top, which is just x. On the bottom, I have the square root of 9. So square root of 9 simplifies to 3. Square root of x I cannot simplify. Nothing gets to come outside, so we just leave it like that. Keep in mind that we are not yet rationalizing denominators. So if you end up with a radical in the denominator in these quizzes, it's okay. You do not have to do anything to try to fix that. All right, last one that goes with quiz 1. What radical is equivalent to the expression below? Use the FOIL method. So, of course, FOIL is nothing new, but we have to multiply. Remember that when we have a radical times itself, that's going to give us the same thing, but without the radical symbol. So square root of x times square root of x is just plain old x. Now, when I multiply my outsides here, -2 times radical x should look just like this, because that 2 is not underneath a radical. So make sure you don't put it underneath here. It doesn't go there. Inside terms gives me plus 5 radical x. Again, don't put the 5 underneath. And then lasts 5 times -2 gives me -10. So like terms here in the middle. We treat radicals when we're adding and subtracting them just like we would variables. So if you just had -2x plus 5x, it would be 3x. Same idea here, except instead of x, it's radical x. So I have x plus 3 radical x minus 10 for my simplified product. All right, so that will take you through quiz 1. Example 4 and 5 that we're going to do here are going with quiz 2, and these are focused on the dividing of the radicals. So for the ones on the second quiz where we're talking about division, we have some of the same things. So what inequality represents all values of x for which the quotients below are defined? So these ones we are not simplifying. It's just like example 1a up here, where we're trying to figure out, okay, what does x have to be in order to not have negatives under the radical and not to have 0 in the denominator? My suggestion is with these, because it is division, is to actually write it in fraction form first, because that can help us see. First of all, we know that 11x squared has to be greater than or equal to 0. In the denominator, we know, yes, okay, 3x has to be greater than or equal to 0 to not have a negative underneath. But we also know this is not allowed to equal 0, because that would give us this 0 in the denominator up here, which we can't have. So for this one, it's actually just a plain greater than, not a greater than or equal to in this case. So if I solve each of these, here dividing by 11 gives me x squared greater than or equal to 0, square root both sides. This gives me x greater than or equal to 0. Here just divide by 3, x greater than 0. So greater than and greater than or equal to are not the same thing. One includes 0 and one does not. If this one says we can't include it, then we can't include it. So the answer here would be just x greater than 0. You can be sure that if it's multiple choice, that they're definitely going to have one with the equal sign on it. So just be looking out for that, because that's going to be important. So now if I look at the next one, again, my suggestion is to write them in fraction form. So here in the top, I know that 6 times x minus 2 has to be greater than or equal to 0 to not have negative under the square root. Here, I can't have a negative, but I also can't have a 0. So I know that 5x squared has to be greater than 0. So this is going to give me x greater than 0. The top, I divide by 6 first. That gives me x minus 2 greater than or equal to 0. Add 2 to both sides, and I get x greater than or equal to 2. So we don't need to list both of these because they're both the same symbol. They're, bigger. So bigger than 0, bigger than or equal to 2. Well, 2 is already bigger than 0. So greater than or equal to 2 is the more restrictive one. And so we take that one, because if it's greater than or equal to 2, it's automatically already greater than 0. All right, last one of this type. So I've got x plus 5 in the numerator and 4 minus x under the square root in the denominator. So I know x plus 5 has to be greater than or equal to 0, and I know 4 minus x has to be greater than 0. So on the top, I just simply subtract 5 on both sides, so that gives me x greater than or equal to negative 5. On the bottom, this is a couple steps. First, I have to subtract the 4, so negative x greater than negative 4. Then divide by negative 1. Remember, when we multiply or divide by a negative, that forces us to flip the symbol. So that gives me x is less than 4. So because these have different symbols, both of these things have to be true. So it has to be greater than or equal to negative 5, but it also has to be less than 4. That's where we come up with what I call an inequality sandwich. So x is between negative 5 with an including negative 5 because it has the equals here, but also less than 4, no equal sign here. So that would give us this for our restriction. So we can only have x between those values if we want it to not violate one of these major rules. All right, so last one is actually simplifying quotients. So if I do the division here, I've got 21 times x plus 2 on the top. I've got 7 x plus 2 squared in the bottom. And just like we did up here, I'm going to reduce the fraction first. So 21 and 7 both divisible by 7. So 21 divided by 7 is 3. 7 divided by 7 is 1. Now these guys are the same expression, so that means that if I have one of them up here and two of them down here, that I can reduce this one, and that takes away the squared. So I end up with 3 in my numerator, and in my denominator I have x plus 2. Now we could write it like this, or we could write it like this. You may see either in your answer choices. It doesn't matter. These are equivalent to each other. Yes, there's a radical in the denominator. We are not yet rationalizing in this lesson, so you don't need to worry about it. You will have answers that have radicals in the denominator still. All right, so I'm going to do the same thing here. I've got 27x cubed in the top, 9x in the bottom, and even though I wrote them with separate radicals, I'm still going to do the same thing. So 27 divided by 9 gives me 3. 9 divided by 9 gives me 1. Then here, when I divide, I subtract the exponents. So I have 3 multiplied x's in the top, only 1 in the bottom. So it cancels out the 1 in the bottom with one of the ones in the top. So I end up with an x squared. So I get square root of 3x squared in the top, square root of 1 in the bottom. Here, we actually have some things that simplify. In this A example, nothing simplified. There was nothing we could do. But here, I have 2 x's. Remember that x squared is really x times x. So that means I have a pair. So that means my x gets to come to the outside. The 3 doesn't have anything to pair with, so it stays. Square root of 1 is just 1. And we know that in final answers, we don't have to write a 1 in the denominator. So this one actually simplifies to x radical 3, no denominator. All right, C, same idea. I've got 48x to the 6th, and I've got 8x to the 4th. 48 divided by 8 is 6. 8 divided by 8 is 1. x to the 6th in the top, x to the 4th in the bottom. So again, when we divide, we subtract the exponent. 6 minus 4 gives me 2. So I have x squared left up here. That completely cancels down in the bottom. So I have square root of 6x squared in the top, square root of 1 in the bottom. And so very similar to what I had over here, the x squared, because that's x times x, brings an x to the front. Now 6 is not prime. It breaks down into 2 times 3, but there's no pairs in those factors. So that's still going to stay x radical 6. And then just like last time, I have a 1 in the bottom that I don't need to write. Last one for 8-2. So 27x cubed over 75x, both with radicals. So 27 and 75 are both divisible by 3. So 27 divided by 3 is 9. 75 divided by 3 is 25. And then this is an x to the first, so 3 minus 1 gives me 2, so x squared in the top, and bottom cancels. So now I have the square root of 9x squared in the top, and the square root of 25 in the bottom. Here, square root of 9 comes out evenly. That's a perfect square, so that's just 3. Square root of x squared comes out evenly. That's just a plain old x. And the square root of 25 also comes out evenly. That just gives me 5. So 3x over 5, or you also might see it written 3/5 x. Those are the same thing and equivalent. So again, sometimes you're going to end up with radicals in the denominator. We're not rationalizing yet, so don't worry about those. Make sure that you ask if you have questions.